Okay, so let's look at an example. This example problem says a sample consists of 1 mole of argon. It is expanded isothermally at 0 degrees Celsius from 22.4 cubic decimeters to 44.8 cubic decimeters. And it wants you to calculate it reversibly, when it's done reversibly, B, when it's done against a constant external pressure that is equal to the final pressure of the gas, and C, freely against 0 external pressure. What is the work for each process? Okay, so let's start with part A. Part A is the calculation of work for the reversible process. And remember, we said anytime we see that keyword reversible, that means that we're using the equation for work being equal to negative nRT, natural log of V final over V initial. So the keyword reversible, that tells us what we're looking for. Alrighty, so we have our N value, we know our R, and we know our temperature, we know the final volume, and we know the initial volume. So we can just substitute. We can just plug our values in. The N value is 1 mole. R in work calculations equals we use the R with the energy units already embedded, and that is joules per Kelvin mole. Our temperature is 273 Kelvin, and our final temperature is, our final volume, should be Kelvin here, is going to be 44.8 cubic decimeters, and that's the unit that we always want to have our volume in, 44.8 cubic decimeters and 22.4 cubic decimeters. Let me see if I can write that a little bit more legibly. This stylus is a little too thick, but we're going to correct that on our next set of videos when we get our smaller one fixed. Okay, so we have 44.8 cubic decimeters and 22.4 cubic decimeters. Alright, so we're going to end up with our units of decimeters cubed canceling. Our unit of Kelvin will cancel with that one. Our unit of moles cancel. And so our final answer is going to be negative 1874.1, and that is in the unit of joules. So that's for part A. Now let's look at part B. Says that we are talking about a constant external pressure, where that pressure that we're referring to is equal to the final pressure of the gas. We don't have the final pressure of the gas given, but we have all the information that we need in order to calculate the final pressure of the gas. We have our number of moles, we have our final volume, we know our R value, we know our temperature. So we can calculate the final pressure. So calculating P final. P final is equal nRT over the final volume. So we know how many moles we have. 1.00 moles times R. And this time, you want to use a value of R that allows us to have our pressure in our final calculation to be in Pascal. We could use the same value of the gas constant that we normally use and then convert the final pressure to Pascal, but it's just more simple to go ahead and incorporate the correct unit as we go along. So 3.14 liter Pascal per mole Kelvin times our temperature, which is 273 Kelvin. And then we divide that by our final volume, which is 44.8 cubic decimeters. We know that a cubic decimeter is the same thing as a liter. So now we just simply do our cancellations. Our moles cancel, our kelvins cancel, our cubic decimeters cancel, our liters cancel, and we're left with an answer for the value of our pressure at being 50.6 Pascal. Now, that's our final pressure. So now we were asked to calculate the value of work. So then, our value of work for a process under constant external pressure is P external times the change in volume. So our external pressure is 50.6 Pascal. And remember, our unit of joules is the same thing as a Pascal meter cubed. So we want our pressure in Pascal, and we want our volume to be in meters cubed. So our final volume is 44.8. Our initial volume is 22.4. And this is decimeters cubed. And since we need to convert that, we're going to cube the whole thing. And there are 10 decimeters in 1 meter. So therefore, this is going to be the equivalent of dividing this by 1,000. We cube the entire thing. That gives us, let me clean this up a little bit. All right. So when we take into account our units, our decimeters cubed will cancel, and our final value for work will be in the unit of joules, 1.135 Pascal meter cubed. Same thing as saying 1.135 joules. The last thing that we've got to do is part C, which is to calculate work in a free expansion. By very definition, a free expansion process, the value of work is simply 0. Okay, the next couple of problems are for you to practice on your own. The problem that we just worked actually combines all three concepts that we just described. Calculating work in the case of constant external pressure situation, calculating work in terms of a reversible isothermal expansion, and calculating work in the case of a free expansion. And so these couple of problems here are in your handout, and they are for you to practice. Okay, so let's take an example of how we use these equations. So this example problem, so the next thing we're going to do is talk about how we measure heat. I'll see you in the next video.